So basically for this chapter, you want to study the relationship between two variables, which is independent and also dependent. So we only have two variables, x and y. Okay, so basically for x is independent variable and y is dependent variable. Okay, so simple linear regression is the big things lah yang we study the relationship between two variables. And then for correlation, so basically this one is to measure the strength between two variables, between the relationship between two variables. So actually this one measure the strength. So either weak, moderate or strong. Okay, so first we focus on correlation. So correlation analysis is the study of the relationship between variables. So the basic idea is to report the strength of the relationship between two variables, which is the dependent and independent. So the usual first step is to plot the data in scatter diagram or scatter plot, which is a chart that portrays the relationship between two variables. Actually, if you do scatter plot, you can see the relationship between two variables either increases or decreases. Okay, the dependent variable y. So actually for dependent variable, we use symbol y, which is if we draw a scatter plot, dia berada di y-axis, and then independent variable is x, which is x-axis. Okay, dependent variable is the variable that is predicted or estimated. It also called the response variable. So this is another name for dependent variable, response variable. Okay, independent variable x is the variable that provides the basis for estimation. It is also known as a predictor or explanatory variable. The strength of the relationship between the dependent and independent, so we can express using coefficient of correlation. Okay, so first, to measure the strength between relationship between two variables, actually you need to follow three types of measurement lah. So first, you need to find coefficient of correlation, which is R. Okay, and then second step, coefficient of determination, which is R squared. Okay, the last one is you need to test using hypothesis testing. Unit test. Okay, so all these types, so you can follow one by one. First step, you need to find coefficient of correlation. Actually, it depends on the marks from each question. If they only mention about coefficient of correlation, so just find the value of R. But if they mention about relationship between variable and then the marks is big, so you need to do all these three measurement. So first you need to find coefficient of determination and correlation, and then followed by determination, and the last one you need to do testing. Okay, so coefficient of correlation is introduced by Carl-Pearson. So we use symbol R. Okay, it's used to describe the strength of relationship between two set variables. Okay, so actually this one either weak, moderate, or strong relationship. Okay, so basically for R, it can take any value from -1 to +1. Okay, so if the value is -1, so means that this one is a perfect negative correlation. So the scatter plot below show perfect and perfect positive and negative correlation. So actually, simple linear regression, same with the linear equation, which is if you want to find the equation of linear, so actually we use y equal to mx plus c. So this one also same with the simple linear regression, but we use y prime equal to bx plus a. Okay, so b and a is coefficient of regression, linear regression. Okay, so this one, if you want to find the slope, so basically we use m equal to y2 minus y1 divided by x2 minus x1. Okay, so this one, if our m is negative, so means that our gradient is negative. Same goes to this one lah. Line has negative slope. Okay, and then after you calculate the value of r, so you will get the value of r is negative. Okay, so negative means that if x increases, y is decrease. Okay, so this is the relationship between two variables. Okay, so if r equal to -1, so means that this is perfect negative correlation. So you can see that all point is in line with the straight line. Okay, so all point attached to the line. Okay, so this is perfect negative correlation. Okay, and then this one is positive slope. Okay, so you can see the gradient is positive value, and then r also positive value. Okay, and then this one is same goes to the negative slope, but Bayesian slope lah, and then negative and positive. So this one, if x increase, so y also increase. This one, if x increase, y is decrease. Okay, so this is the difference between these two relation. Okay, now you can see the point also attached to this line. So this is perfect positive correlation. Okay, if there is absolutely no relationship, means that your value of r is 0. Okay, if after you calculate the value of r, you get 0, means that there is no relationship between two variables. Okay, if r is close to 0, so the relationship is considered weak. While an r value close to 1 or -1, so it indicates that the relationship is strong. Okay. So the scatter plot below shows 0, weak and strong correlation between variable x and y. So first this one, okay, you can see that this line, we don't have any relation between x and y. So this is no relationship. Okay, so your r equal to 0, and then you can see that all point is far away from each other. And then you don't see any pattern, so just uniform line. Okay, so this one, weak correlation. Okay, so if x increase, y decrease, so this is negative correlation. So from this one, point is not too far and not also too close, so this is weak correlation. Okay, there are perhaps is negative something. Okay, negative as if weak, so negative 0.3 for example. Okay, and then strong correlation, you can see that most of the point is attached in this line, so this is strong correlation, but this one is negative. Strong negative correlation. So r equal to negative value lah, negative 0.8 for example. Okay, so this one is strong correlation, weak correlation, and zero correlation. Okay, the following summarize the strength and direction of the coefficient of correlation. So perfect negative correlation is equal to 1. Okay, if you get the value of r is equal to 1, -1, so means that this is a perfect negative correlation. Okay, and then if your value of r is negative 0.8, so this is strong negative correlation. Okay, and then for moderate, we get the value is negative 0.5. And then for weak, okay, so the value of r is in between 0 to negative 0.5. So this one is considered weak negative correlation. Okay, and then if r equal to 0, so means that there is no correlation, so no relationship. Okay, and then for this one, positive correlation. So if R equal to 0.3, so this is weak positive correlation. And then for moderate positive correlation is positive 0.5. And then if R equal to positive 1, so this one is perfect positive correlation. Okay, so actually it depends on the value of R. So to find the value of R, we have two formula. This is the first formula. The conceptual form of the coefficient of correlation is as follows. This is the first formula. Okay, and then this is second formula. So basically we use second formula because this one, you need to find the value of summation xy and then summation of x power of 2 and then summation of y power of 2, summation of x and also summation of y. So this all value you need to use if you want to find the linear regression equation. So that's why we use second formula because this one kita akan dapat the whole things. Okay, you can find the simple linear regression equation using this formula. Okay, so R equal to N. N is number of observation times summation of X times Y. Okay, X is independent variable and Y is dependent variable. Okay, just substitute the value. So you will get the value of R. Okay.